The ocean is the cornerstone, the blue heart of our life support system. It has been stable for millions of years.
I think if you ask anyone, is the ocean important to them, they would probably say yes. We all somehow seem to be touched.
Oceans are such a vital part of our planet. There is such amazing biodiversity.
Human civilization depends on the ocean. It's given us the stable climate that humans have thrived upon.
The oceans provide the oxygen that we breathe, the food that we eat, the water that we drink.
We're burning coal and oil to get energy to make our lives more comfortable. From this, we're also putting carbon dioxide into the atmosphere. Some of that carbon dioxide, about 30%, ends up in the oceans, changing the ocean's chemical composition.
We're adding 2.3 billion metric tons of carbon into the oceans every year.
Humanity has changed without question the chemistry of the oceans on a global scale.
The last time the ocean was as acidic as it is now was 50 million years ago, and that change occurred over millennia, not over decades.
We used to think the ocean had an infinite capacity to accept abuse. We know that isn't true.
Life in the ocean is sensitive to the chemistry of the ocean. Change the acidity, you're changing everything.
The Wendy Schmidt Ocean Health XPrize is a 2-year competition worth $2 million for teams to create radical breakthroughs in the measurement technology.
The point of this competition is to accurately measure ocean acidification for the first time.
It alerts people to the fact that we've got a problem. It's so important that somebody's willing to put up private resources as a reward.
One of the goals of this prize is to bring more instruments to the problem.
We have such a pitiful amount of data.
We need the measurements to know exactly what's going on. This is a real opportunity to start fresh with new tools and a new data set that the public understands what we're doing to the global oceans.
First thing is they had to go through the laboratory trials where we created a controlled environment to determine just how well they measured the pH of ocean water. The teams that could make it through that phase went on to the semifinals, the coastal trials in Seattle, where they had to experience a full month of measuring the chemistry of Puget Sound. Only the top 5 finalists were announced for opportunity to go on to the deep sea trials and eligibility for the $2 million grand prize purse.
We're Team A and B.
I'm Team Sunburst. Team Silo.
Team XPHS.
Team Durafet, and we're ready for phase 4.
Boom!
Building a sensor is a hard thing. You've got to build a little tiny instrument that's going to find this part per billion of a part per billion in the ocean. It's got to stay out in the water at crushing pressures and sift through all the water molecules and all the salt and count it.
We had about 20 sensors in this massive tank, measuring things that are happening in the water that led to corrosion on the metals that were holding on to these sensors.
I was not surprised that there were complications. I was a bit surprised that in particular it was this corrosion.
Nobody thought this could be this rapid a corrosion. So we brought in these experts, identified the problem, resolved it, and were able to move through on the competition. But there was a point where most of us didn't know if there would be a winner.
It looks like some of the spigots at the top screwed themselves loose. Some are completely missing, some are just loose. Very uncommon.
That's why we run the competitions out here, because you can't do it in a lab. You gotta do it out at sea. But damn, it's freaking frustrating, to be honest with you.
From complete concept to competition, we had about 4 weeks to develop the sensor.
The first 3,000 meter cast was 5 hours of anxiously waiting to see if anything survived.
Team A and B had essentially a structural failure of their casing. The battery compartment completely compressed and destroyed the battery, so they lost power. The data recorded all the way down until that crushing happened. It's about 2,400 meters.
The furthest tests we had done before this were 3 meters in depth. So getting to 2,400 meters is a real achievement for us.
The exciting part of the competition is seeing the team scramble to find a resolution. I think these challenges are good. That's what makes a more robust, better sensor in the end.
The second place prize of the accuracy purse is Team Durafet. Second place in the affordability purse, A and B sensors. And the grand prize winner is Sunburst Sensors.
Most people only experience the oceans from 35,000 feet. They look down and say, this is really big. How could we possibly be affecting this?
The ocean is critical to keeping us alive. Never again will we have as good a chance as we now have to take action.
We've proven that innovators can solve the grand challenge of building a breakthrough pH sensor. The next step is all of the rest of the world being inspired to take this and solve the challenge of ocean acidification.
It's going to totally change the way oceanography gets done.